A very warm welcome to today's class, and so I hope you're clear with the basic concepts from the previous class. So now in today's class we will be solving some of the problems, and before getting into the class let me just give you a result which we have derived from the previous class itself. So in previous class we have found out HCF and LCM, and we have seen how to find out the HCF and LCM when the prime factorization is given. So when the prime factorization is given, what we have to look for is we have to look for the lowest power for a common factor in the case of HCF, and in the case of LCM we don't have to look for the common factors, but we have to take the greatest power of each factor. We have to take the greatest power of each factor. So now we know the HCF and LCM. There is a result that we should know which by which we can calculate the HCF and LCM. If one of either HCF or LCM is given, we can calculate the other. If the HCF is given, we can calculate the LCM, and if the LCM is given, we can calculate the HCF. So this is our result. So for any two positive integers a and b, the formula goes like this: HCF of a and b into LCM of a and b is equal to a into b. Okay, so suppose we are having a number, okay, let's say HCF of 2 and 4 into LCM of 2 and 4 is equal to 2 into 4. I'm just telling you an example for the sake of it. Okay, so in this way we can use this formula to find out either the HCF or LCM when one of which is given. Okay, so let's just start with one problem. So this is our example 3 question. So here the question goes like this: find the HCF of 96 and 404 by the prime factorization method. So we have to use prime factorization method for both for HCF, and hence find the LCM. Okay, so here first we have to find the HCF, and by using that HCF we have to find the LCM. So first of all, to find the HCF we have to start with the prime factorization. So for that, prime factorization of 96 we have to do, and also 404 we have to do. So for starters, I will show you how to. So here 96 is an even number. Like I said, we can start with 2 for even numbers. So 96 divided by 2, what it will be? It will be 48. Now 48 again, it's an even number, so we can divide with 2. 48 divided by 2, it's 24. Now 24, it's again an even number, so we can divide it with 2. So 24 divided by 2, it's 12. Now 12 again is an even number, so we can again use 2, and 12 divided by 2 is 6, and 6 is again an even number. We can divide it with 2. 6 divided by 2 is 3, and 3 can only be divided by 3 itself. So 3 divided by 3 we will get 1. So this is a prime factorization. So 2, 1, 2, 3, 4, 5. 5 times 2 and 3 one time. So the prime factorization of 96 is equal to 2 raised to 5 into 3 raised to 1. Okay, 2 raised to 5 into 3 raised to 1. Now 404. So here 404, the again even number, so we can divide it with 2. Now 404 divided by 2, it's 202. Now 202 is again an even number, so we can again divide it with 2. 202 divided by 2 is 101. Now 101, can we divide it with any numbers? So the thing about 101 is it's a prime number. So we can only divide 101 with 101 itself. So 101 divided by 101, it's 101 itself. So this is our prime factorization of 404. So let's just write, there are two times and 101. So we can write it here, 2 raised to 5 into 101. So that's about the prime factorization of 404. Now, from this prime factorization, we should know what is the HCF of 96 and 404. So here the factors are 2, 3 and 101. So for HCF, we have to take the common factor. So when we look at 96 and 404, the common factor is obviously 2. 2 is the common factor. Now, within 2, we have to take the smallest power. So here 2 raised to 5 is the smallest power. So here it's not 2 raised to 5, it's 2 raised to 2. So 2 square is our smallest power. So the HCF will be 2 square. Okay. First of all, the path of thinking is that we have to look for common factors. So here the common factor is 2, and then we have to look for the smallest power of 2. Here the smallest power of 2 is 2. So the HCF of these two integers, or the HCF of 96 and 404 is 2 raised to 2, which is equal to 4. So HCF of 96, 404 is equal to 4. Now we have to find out the LCM. Now for that LCM, we can use this formula. So here LCM of A, and the formula is, we already know, HCF of A comma B is into LCM of A comma B is equal to A into B. So from this we can take LCM and take HCF to the right hand side. Then we will get LCM of A and B is equal to the product of the two numbers divided by the HCF of the two numbers. So here LCM of 404 and 96 will be equal to the product of the two numbers, which is 96 into 404, the whole thing divided by the HCF of the two numbers, which is 4 itself. So 96 into 404 divided by 4. From here itself we can cancel either 96 or, okay, we can cancel 404 with 4. We will get 101. Now 101 into 96, and that will be our answer. So 96 into 101, which is equal to 9696 as the answer. So that's our LCM. So our LCM of 96, 404 is equal to 9696. So that's about this question. So I will explain the structure again. So first, obviously the first part is our prime factorization. So that's our first part. Now second part is to find out the HCF. So when we find out the HCF, we will get we can use that in the formula. Now after using in the formula, we will get the LCM as 9696. Now let's move to the next question, which is example 4. So in example 4, we have to find the HCF and LCM of 6, 72 and 120 using the prime factorization method. Now what we have 6, 72 and 120. So again, here the first step will be the prime factorization. So for that we know the prime factorization of 6, it's obviously 2 into 3. Now for the prime factorization of 72, if you don't know, you can also use the same step. 72 divided by 2, it's an even number, so we can use 2. So 72 divided by 2, it's 36. Now again 36 divided by 2, it's 18. Now 18 divided by 2. What is 18 divided by 2? Okay, 18 divided by 2, it's 9. And 9 we can only divide with 3, and it's 3. And again 3, we will get 1. So the prime factorization will be 2 3 times and 3 2 times. So 2 raised to 3 and 3 raised to 2. 2 raised to 3 into 3 raised to 2. Now again 120 we have to do the prime factorization. 120 divided by 2, it's 60. And 60 divided by 2, we will get 30. And 30 divided by 2, it's 15. Now 15 divided by, only we can divide using 3. Okay. So 15 is not divisible by 2, so we can try for 3, and it's divisible by 3, and it will give us 5. Now 5 can only be divided by 5 itself, so that's it. So 2 we have 1, 2, 3, 3 times, and 3 1 time, and 5 1 time. So 2 raised to 3 into 3 raised to 1 into 5 raised to 1. 2 raised to 3 into 3 raised to 1 into 5 raised to 1. So that's our prime factorization for 120. Now, we have the prime factorization of all the 3 numbers. Here, for HCF, we have to look for the common factor, then we have to look for its least power. So here, in all the 3 numbers, we have 2 and 3. So 2 and 3 is the common factor. But in among these, which is the, now we have to look for the least power. So here 2 raised to 1 and 3 raised to 1 is the least power. All others, they have 3 as the power and 3 as the power. So only 3 raised to 1 and 2 raised to 1 is the least power. So 2 raised to 1 into 3 raised to 1 is what we are going to take. So here 2 raised to 1 and 3 raised to 1 are the smallest powers of the common factors and factors of 2 and 3. So here HCF of 6, 72 and 120 will be equal to 2 into 3, which is 6. So 6 will be our answer. Now going for the LCM, we don't need common factors. We need all the factors, but we should take the highest power of each factor. So the highest power of 2 will be 2 raised to 3. So 2 raised to 3 we will take. Then the highest power of 3, which is 3 square. So 3 square into the highest power of 5, it is 1 itself. So 5 raised to 1. So that will be our LCM. So the LCM of 6, 72 and 120 will be equal to 2 raised to 3 into 3 raised to 2 into 5 raised to 1. So which is equal to 2 raised to 3 it is 2 into 2 is 4, 4 into 2 is 8, and 8 into 3 which is 24, 24 into 3 which will be 72. Now 72 again into 5 we should get 360 will be our answer. So the answer is 360. Now an interesting factor about the three now when there are three numbers we have to find the LCF and LCM. The thing is that this kind of formula doesn't work there. When we have A, B and C, this formula doesn't work. Okay, so here if you see 6 into the product of 672 and 120 will not be equal to the product of HCF and LCM. So that is one thing you should remember. For if there are three numbers, we have other formula. Okay, the previous formula doesn't work when there are three numbers. Now if you're curious about how to do the HCF and LCM just directly, this is a method. Now we just wrote 672 and 120. Now all the three numbers are divisible by 2, so I will divide first with 2. 6 divided by 2 is 3. 72 divided by 2 which is 36, and 120 divided by 2 is 60. Now here all the three numbers are only divisible by 3. So 3 divided by 3, 1. 36 divided by 3, 12. 60 divided by 3, 20. So that's it. Now the next numbers, we don't have a common factor, so we stop here. So here the HCF will be equal to 2 into 3, which is equal to 6. So 6 is our HCF and that's our answer. Now if you're trying for LCM, again 672 and 120, we will do the same. We can divide it with 2 and we will get 3, 36 and 60, and again we can divide it with 3, then so again we will get 1, 12 and 20. Now here, what if in the case of LCM, what we can do is if there are common factors for two numbers, then also we can do it. So for example, in 12 and 20 we have a common factor. What is it? It's 2, right? So 12 divided by 2 it's 6, and 20 divided by 2 it's 10. Again we can use 2. Now 6 divided by 2 it's 3, and 10 divided by 2 it's 5. So for the case of LCM, our answer will be 2 to the power of 3, which is 2 cube into. So in the case of LCM, what happens is all these numbers will come and also the numbers below will come. So LCM will be equal to 2 into, so 2, how many 2's are there? 1, 2, 3. So 2 to the power of 3 into 3, how many 3's are there? 1 here and 1 here. So 3 to the power of 2 into 5. 5 is only one time here. So 5. 5 to the power of 1. So that's our answer, and we will get 360 as the LCM. So that's about the normal method. This is our normal method. This way also you can do. You can do the prime factorization and then also you can write the answer. So I just wanted you to know this. Okay. So now let's move to the next exercise 1.1 question, which is to express the given numbers as a product of its prime factors. So first number is 140. So what we can do is we can do the prime factorization and just write it down after that. So 140, we can, again it's an even number, so we can start with 2 itself. So 140, it's divided by 2, we will get 70, and 70 divided by 2 we will get 35, and 35 can only be divided by 5 or 7, so we will take the 5. Now 35 divided by 5 it's 7, so 7 can only be divided by 7 itself, so it's 1. So 140 we can write it as 2 times, so 2 square into 5 one time and 7 one time. Now the next one, this is about our first question. Now second question, it's about 156. So for 156, what we can do is, okay, second question, 156. It's again even number, we can start with 2. Now 156 divided by 2, it will be 78. So 78, again it's an even number, divided by 2, it will be 39. Now what about 39? Oh, is it divisible by 3? If we take 3, it's obviously it's an odd number, so it is not divisible by 2. So we take 3. Now when we divide 39 with 3, what we will get? 1, 3, 13. Now 13 is a prime number, so we cannot divide it further, so this is our factorization. So we can write 156 is equal to 2. How many 2s are there? 2 2 times, and 3 and a 13. So 13 divided by 13, it's 1. So here 2 raised to 2 into 3 raised to 1 into 13 raised to 1. So this is our prime factorization of 156. Now what about 3825? What we will do with 3825? So for 3825, we can again start with, can we start it with 2? No, it's not an even number, so we have to look for other factors. So we can search for 3. So what we can do with 3? So now 3825 divided by 3. So it will be 825 divided by 3. In 3 there are 1, in 15 we have 5 times. So 1275, it's again we can try for 3. Now in it's 400, 425. Now it's 425. Can we try it with 3? No, it's not possible. So we have to try for the next possible prime number, which is 5. So 425 divided by 5. What will be the answer? Now when we try for 5, we have 85. Now again, we can divide 85 with 5 itself. So we will get 17. Now 17 is a prime number, so it will only be divisible by 17 itself. So that's about our prime factorization. So here 308, sorry, 3800, 3825 is equal to 3 how many times? 1, 2. So 3 square into 5 square into 17. So this is our prime factorization of 3825. Now our next question is 5005. How can we do the 5005? Is that simple? So for 5005, let's try with the, okay, 5005, it's not divisible by 2, so let's try with 5 itself. So 5005 divided by 5, we will get 1001. Now is this divisible by any numbers? 1001. Okay, after 5, let's just try for 7, the next prime number. So 7, it's 143. That's what we get when we divide 1001 with 140. Sorry, 7. Now again 143. We can try with the next prime number, which is 11. It's obviously not divisible by 7 or 5, so we are trying for 11. Now 14 divided by 11, we will get 1 and balance, so 13 we will get. Now 13 divided by 13 itself, it's 1. So the prime factorization of 5005 is equal to 5 into 7 into 11 into 13. In the same way, we will, for 7429, we will get 17 into 19 into 23. So this is a bit difficult, 7429, to know where to begin is a bit difficult. So you have to start trying with 3. Obviously it's an odd number, so you have to try with 3. If it is not possible, you have to go for 5. So it's not possible because when we look at the last digit, it's not 5, so it's obviously it's not divisible by 5. Then we have to try for 7, we have to try for 11, we have to try for 13. After that, we have to try for 17. So when we try for 17, it will be divisible. So when you try for 17, what you will get? So when we divide 7429 with 17, we will get 437. And when we divide 437 with 19, which is the next prime number, we will get 23. Now 23 is also a prime number, so it's only divisible by 23 itself. So we will get the answer. So that's about 17 raised to 1 into 19 raised to 1 into 23. So that's the prime factorization for 7429. Okay, that's about today's class. So we have seen how to do the prime factorization, and also we have seen how to find the HCF and LCM by prime factorization. And also for if there are only two numbers, we can use this formula to find out the HCF or LCM when one of the HCF or LCM is given. So that's about today's class. We will see about the next problems in the next class.